Hey, and welcome back to this video about Soul. In the last video, we talked a bit about the understanding that we need to implement our Soul patches, understanding in the sense that we want processes, graphs, and connections and entry points for our data to process. We talked a bit about this in the last video, and in this video, we're going to apply some of this and implement a simple volume slider that we can use in Soul. So that's what we're going to do today. I am in the online IDE. I'm at soul.dev, and I'm going to click on try Soul in your browser, which is right here. Alternatively, you could also click on Playground. This is going to give you the, by now, iconic classic ringtone example that you might have listened to already. I don't really need that. I need something new. So I'm going to click on New Soul Patch right here. I'm going to give it a name. I'm going to call it Gain Slider. People will always criticize your naming, so better choose a decent one. We could give it a description. I think this is self-explanatory in and of itself, so I'm going to leave this blank. You can, of course, go ahead and write a nice little description about your first Soul patch. We could say that this is an instrument. This would tell the host that we would run our Soul patch in to say, hey, this is a MIDI instrument, please hook up all the necessary stuff for us. But since we're not going to use MIDI in this video, at least, we're going to leave this blank. So I'm going to click on create, and this is going to leave us with a nice bit of comments. And I'm going to delete all of these. Now, before writing this, I'm going to talk a bit about the ecosystem. Here is where you have all your source files that you're basically going to use. In case you're using MIDI, you also have a MIDI keyboard right here, a virtual one. Here we have our audio input that we can choose, which is going to be like our test signal for our Soul patch. This is what top level graphs or top level processes would use as an input signal. I'm just going to click loop just because I'm always forgetting that. And then on the right hand side, we can compile and like stop our Soul patch. We can bypass it to hear any differences. We also have an oscilloscope right here, and then we can see the frequency spectrum of our signal right here. I'm going to leave this on the oscillator right now. But before we jump into any sort of syntax, I think it would actually be useful to sort of sketch out what we want to do. Of course, this is a very, very simple example, but helps nonetheless. This is how you, oops, zoom in. This is how you write comments in Soul. It's just like most other C-style languages. But what we essentially want to have is we want some sort of processing unit, which takes an input signal. This is one word. Multiplies input by a certain value. And lastly, it's going to push the scaled input to our output. So this is what we're going to end up with. So for this, we need to declare a processor. And a processor is declared using the processor keyword. And then I'm going to give that a name. I'm going to call it gain. I'm also going to leave this with a capital letter, just because it's a structure that we're implementing ourselves. And then lastly, we're going to define the scope of this processor with these two parentheses, just like you're used to it from other C-style languages. Now, remember in the last video where I talked about these entry and exit points for our processes? Well, this is what we're going to implement next. So for our input data, we want to say that this is going to be a continuous stream of data, and the data type of this is going to be float. So what we're going to say is input stream. This indicates that it's a continuous stream of data that's coming in and that we want to process continuously. Float. And then we're going to give it a name, and I'm going to call it audio in to indicate, well, this is audio data that's entering. Well, This is an input. And then similarly for our output, we're going to say output stream float, and I'm going to call this audio out. And this way we can declare our entry and exit points of our processing units, or processes as they're called in Soul. Now, every processor needs to have a run function. And in this run function, you can think of this run function as this sort of process block that you would use in a Juice project otherwise. But there are some fundamental differences that I want to talk about. First of all, we declare this run function, or this process block. We declare this run function for each processor individually. So instead of having one giant loop, we're going to declare our steps for each processor that we write. So this is the first difference. And the second difference is that Soul processes data on a sample by sample level. So we're not getting any buffer that we then iterate over and then push it outward. What we have instead is we processing sample by sample. So we do not iterate over anything. This is at least the way, the level of abstraction that we're going to work with when writing Soul code. And this processing function is called void run, or we're going to implement it as void run. And this is going to, and here we're going to declare all the processing steps that we need. Now, if we just were to write a formula right here, this would only run once. So what we need instead is we need some sort of infinite loop, and we can just use the loop keyword right here, followed by the scope, where we declare our instructions. And what we essentially want to do is we want to take our audio out. So this is where the data is going to exit. And then we're going to use this bit shift operator. This might look a bit unwieldy to you, but you will get used to it at some point. This bit shift operator is actually going to say, okay, whatever is on the right-hand side, which is going to be our audio in, push it into our audio out. This is how we do that. And the last thing that we need is we need to shift time. It's like we could happily go ahead and run this or compile this, but this would throw us an error which says the run function must call advance. And advance is essentially just taking time by one sample, or shifting time by one sample. So what we're going to do is we're going to say advance, call this advance function right here. And this way, this is compilable. This actually works. Now, this of course doesn't do anything. It just throughputs our input signal. It doesn't do any operations to it. So whether or not it's actually working, we can't tell the difference right now. So what I'm going to do instead is I'm going to just break it and say whenever this patch is active, well, we want silence. This is all we want. Then we're going to hit compile. Going to go in this bottom left-hand corner. Going to click on play, and as you can hear, you don't hear anything. But if we bypass our Soul patch, then we actually have our signal. So we can indeed say, well, this is working. And well, all that's left to do is we need our audio in, and we need to multiply that by a certain scalar. Now, we could just go ahead and like hard code some value in, but this doesn't get us anywhere. So what we need to do instead is we need to introduce parameters. And naively, we can use user parameters in the same way as we would use our audio data, or audio in right here. So what we could go ahead and do is we could say input stream float, and then we're going to give it a different name. We're going to call it gain in, for example. This would all work fine and well, but we want some sort of interaction with it. We want to make this a user parameter. And for this, we're going to use annotations. Annotations, the syntax for this are these these double brackets right here, everything that's inside there. This is basically an annotation that tells the host, so whatever your soul patch is running in, hey, please provide some parameters for this. And we can specify certain properties of these parameters in the same way that you would specify properties for a slider that you're implementing in Juice, for example. So there's certain key value pairs right here. So we can say, well, we want a minimum value, which is min. Actually going to leave a space right here. And this is going to be at -40. I'm going to do it on a dB scale. We also have a max value, which is going to be at 0. We can have an initial value, which is init, and this should be at -6. We can also give it a step size, so step, which is nothing but the resolution, so how coarse or fine you want to be able to interact with the slider, which is going to be 0.01 for me. And then lastly, we also want to give it a name, which I'm going to call gain. That's it. And lastly, I also wanted to specify unit, and this is going to be in decibels. So this would work just well. And what we can go ahead and do is we can compile this for now and see if anything shows up in our UI. And indeed, also forget to press pause on this. But in here on the right-hand side, we actually have this slider right here that we can interact with. So this is how we can define user parameters. And then one thing that's left to do is we need to replace this with our gain in. And I'm not going to compile this right now because I'm specifying this parameter on a dB scale, but this operates, well, on a scale from 0 to 1. So what we actually need to do is we need to convert this, and we can use an inbuilt function that Soul provides, which we're going to access in the similar way that we would access any namespace in other C-style languages, which is Soul. This lives in the Soul namespace, : : and then the function is dB to gain, and it takes our gain in as our input parameter. So hope I didn't make any typos. Let's see if this compiles. Works all well. We're going to click this. And if I were to move the slider, then we should get a decrease or an increase in our signal. And this works just well. So now we basically have a processing unit or processor, which also has a user parameter right here that we can interact with. This is great, but there are some problems with this, and there's one problem I'm going to point out right now, and I'm going to introduce events in this place. So remember when I said that whenever we declare a stream, we're saying that, well, we're expecting a continuous stream of data that we're going to process. But for audio in, this is paramount. We need this. But for our parameter right here, we don't actually need this. What we instead want to have is we just want to say, okay, like whenever this value change, we want to do some other operations with it. So instead, we only want to capture a value of this parameter upon change, and therefore we can use events. So the first thing that we have to do is we have to replace the stream with our event keyword. And then there are two additional things that we need to do. First, we need to introduce a new member variable to our processor right here. And I'm going to call this gain value. And this is of type float. And just for safety, I'm going to initialize this to 0. And then another thing that we need to do is we need to write some sort of function that would say, okay, upon change of this event, whenever we receive an event, well, that says, well, parameter has changed, we want to make certain assignments. And we do this by writing a new member function that assigns the incoming value of our volume slider to our member variable, gain value, right here. And we do this by writing the event, and then it needs to have the same name as our event right here. So our entry point, gain in. And then this has an input, which we're going to call float incoming value. And in this function, what we're essentially going to do is we're going to assign our incoming value to our member variable right here. So we're going to say gain value. You could also call it gain. We're going to say gain value is equal to our incoming value. And then one last thing we need to do is we need to replace in our run function, we need to replace this gain in with our actual gain value. And what we've basically achieved is we've reduced our computational cost quite a bit by saying, okay, we only want to receive events on this. And whenever we receive an event on this parameter, we're going to assign the incoming value to our gain value. And then we're going to use this member variable in our calculations. And if I haven't forgotten anything, then this should compile just well. And we're going to see how this goes. Again, I forgot to press pause, but we go play around with our slider. Then this has worked just beautifully. Now, so far you've learned how to declare processes, how to implement them. We also took a look at these entry and exit points. We took a look at the differences between streams and events, and what else you need to, like additional stuff that you need to declare for handling events. There are two problems with this patch right now. And the first problem is that we cannot tell the left and the right channel apart. And for this, we're going to need data structures that are provided by Sol. And the other thing is that we're currently lacking modularity. As I said in the previous video, we also want to connect processes to one another. And this is what graph's for, because most of the time you want your patch to be slightly more sophisticated than just this one processor that just does one trivial operation. And for this, we're actually going to use graphs. But I really want to keep these videos concise and digestible for you. So we're going to look at graphs and data structures like vectors and arrays in a later video. But yeah, I hope this has been helpful for you. And I'm going to see you in the next video. And yeah, take care.